Hello, my name is Ayush and today we are going to create a weather radar using the Signal Processing Toolbox of MATLAB. But what is a weather radar? Weather radar, also known as Doppler weather radar, is an equipment that transmits pulses of electromagnetic radiation into the atmosphere to discover precipitation, measure its velocity and intensity, and identify the precipitation type such as rain, snow, or hail. The basics of radars is that a beam of energy, called radio waves, is emitted from an antenna. As they strike objects in the atmosphere, the energy is scattered in all directions, with some of the energy reflected directly back to the radar. Weather radar are of three types: the S-band, the C-band, and the X-band. The frequency, wavelength, and uses of the three types of radar are shown here. Weather radar consists of a transmitter, which is used for transmitting the electromagnetic energy signal. Antenna is a huge radar dish which hoots pulses into the environment and receives it. Radar processor is used for processing the signals which are reflected back. Receiver is used for receiving and decoding the signal. And lastly, the display system is used for displaying the weather information to the user. Now, let us move to the MATLAB and design our weather radar. Before jumping to the MATLAB code, here is a quick reminder for you to subscribe to our channel for a lot of cool upcoming content on MATLAB. Only 9.5% people have subscribed. Please increase the figure. After opening MATLAB, we will click on Apps, expand the list, and search for Radar Designer under Signal Processing and Communications Toolbox. So what can this toolbox do? This toolbox can calculate all the probable outputs and working of a radar. It requires all the parameters such as the range, frequency, bandwidth, as well as the environmental characteristics like precipitation. You can also decide whether the Earth model needs to be curved or flat, along with the availability of atmosphere, and you can change the radius of the Earth as well. After changing all the parameters as per the requirement, the outputs can be seen, which we will discuss in the later part of this video. The Radar Designer Toolbox is new and came with MATLAB version 2021. After it has loaded, we will click on New Session drop-down list and select Weather Radar. We wish to design a C-band radar, so at first we change the range to 120 kilometers and frequency to 5 GHz and antenna height as 10 meters above the ground. In the Environment tab, we will select the precipitation type as clouds and the cloud type as cumulus. You can experiment with these and try other combinations as well. Now, on double-clicking SNR versus range, we expand the figure. SNR means signal to noise ratio, and as we can see, between 2500 to 3000 kilometers, the SNR decreases sharply. Since our radar is being used for a 120 kilometer range, it isn't a problem. A high SNR is always preferred. The scenario geometry shows the coverage of the weather radar above the ground level. These are the environment losses that our radar faces. Since we have taken an ideal environment with no precipitation, there are no losses. Lens effect loss happens because of atmospheric refractions. This graph shows the Doppler coverage of the radar. We can see a term named blind speed here. The radar blind speed is the speed at which the target will not be seen to the radar. The formula for blind speed can be shown in the figure. After we have seen the output graphs and behaving of the radar we designed, we can export the code as a MATLAB script. For that, we have to click on Export drop-down list and click Export SNR versus Range MATLAB script. This is the script generated after exporting. It contains all the parameters such as frequency, range, environment type, environment losses, etc. On running the script, we can again obtain the graph for the signal-to-noise ratio for our designed radar.
Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future. MATLAB is our future. Happy MATLABing!